be going over Table F today, which is part of our Unit 10 on solubility. Table F allows us to figure out which substances, specifically ionic compounds, which ones are soluble or insoluble. So this can be useful because if we were looking at a double replacement reaction, we would know which of our products would form a precipitate. And precipitate is the solid product that forms as a result of a double replacement reaction. For us in the Regents questions, really it's just about figuring out in a question which is a soluble versus insoluble. So when you look at Table F, it's broken up into 4 columns, but really there's this big divide down the middle. This is important. So on the left-hand side, column 1, these are ions that normally form soluble compounds. Okay, on the right-hand side under column 3, these are negative ions that will form insoluble compounds normally. When we say insoluble, we're talking about very, very low or little solubility in water, but mostly in the Regents, they'll talk about it in terms of insoluble. So a couple of things is, as we look down that column 1, these are ones that all form soluble compounds, but there are exceptions. So for the halides and the sulfates, if they are with one of those compounds listed, it's an exception to their normal rule. So if one of these halides or sulfates are formed with these positive ions, the exception is that it's going to form an insoluble compound. Excuse my handwriting. If we look on the right-hand side, column 3, while those negative ions tend to form our insoluble compounds, when they're with any of these exceptions, and probably the one that gets missed the most are the group 1 ions, which you need to look at your periodic table. So this would be like your sodium, lithium, potassium, you could have rubidium, and so on. So those would be your group 1 ions that you have to be on the lookout for. If it's with a group 1 ion, ammonium, or some other ones that are listed that are specific to the negative ions, this is an exception to its insoluble rule. So if it falls under here, it flips it to be a soluble compound. Okay, so we're going to be kind of going back and forth with that. So how to use Table F is kind of outlined right there. I'm going to kind of just show you a couple of examples, and then you'll do some practice on your own. So using Table F, determine whether the following are soluble or insoluble. So with this first one, we have potassium nitrate. Okay, usually focus in on the negative ion first, which I'm going to kind of just try to put this up for you. So we're going to focus in on the NO3 part. So up here, I find NO3 right here. Okay, nitrate is normally soluble. There are no exceptions, so that means it's going to stay soluble. Okay, if I look at calcium carbonate, and again, I'm going to focus in on the negative ion first. Okay, I'm going to come up here. I'm going to find that carbonate is, carbonate is on the right-hand side. Okay, in my example, it's with calcium. Calcium is not one of the group 1 ions, so that means that carbonate, and it's not ammonium, so carbonate is going to fall under its category of insoluble compounds. So I'm going to write this here, insoluble. All right, moving on to magnesium sulfate, and I'm going to focus in on the negative ion first. Okay, magnesium sulfate is over here on the left-hand side, sulfate right here. When it's combined, now normally it's soluble, unless it's combined with silver, calcium, strontium, barium, or lead. So if you look back down, it was with magnesium. Okay, it's not one of the exceptions, so it's going to stay under the column that it's placed under, which is soluble. So you can go ahead and label that one as soluble. And then finally, number 4, we're looking at hydroxide. Sorry, I know this is probably bugging you going back and forth. With hydroxide, we're looking up here. We find hydroxide over on the right-hand side. It is going to normally be insoluble unless it's combined with group 1, calcium, barium, strontium, or ammonium. And if you look at your paper, it's with ammonium. So that means instead of being insoluble, it's going to flip it to the exception, which will then cause it to be soluble. All right, so you'll see questions in the practice where we'll just say which one is soluble, which one is insoluble. You could also just get something like which one is most soluble, which just means which one is the one that is most soluble. Meaning the other three are going to be considered insoluble, that type of thing you might see in a question. The other thing that sometimes throws off students in questions is when they say which one would have the highest concentration or which one would have the lowest concentration. Whenever you see the most concentration, that doesn't make sense. Whenever you have something like the highest concentration, you want the soluble compound. If you see one that says the least concentrated or the lowest concentration, then you're looking for your insoluble compound. So just make sure you keep that in mind as you go on and do some of the practice. And that's it.